Okay, Bismillahirrahmanirrahim. Hi, Assalamualaikum. We are back. Okay, we continue. Last video is we already discussed or explained about the short and axially loaded column. Okay, kita dah tahu bila mana hanya ada axial load acting on the column. Okay, but the axially loaded column is unusual column, which is very rare, and most of the column will be necessary to use the structural analysis to find the bending moment caused by the load on the frame. Okay, so maksudnya yang the previous one adalah knowledge kita untuk bila mana we are only consider on the axial load acting on the column only. Okay, so now we're going to proceed with the column with uni-axial bending moment. Okay, apa yang dimaksudkan uni-axial bending moment? Okay, usually column ni akan carry both, okay, compressive force and also the bending moment. Okay, biasanya dia akan ada compressive force and also a moment, okay, a bending moment. Okay, the bending moment to be carried out is calculated by the structural analysis. So everyone dah tahu, dah ada knowledge on how to calculate the bending moment by using the structural analysis of the column and the slab or beam that is support, taking into account possible uneven distribution of the load on the beam. So we need to calculate the load in order to calculate the bending moment. Okay, the uni-axial bending can occur in zigzag axis or axis or in YY axis. Okay, seperti ditunjuk dalam figure ini. Okay, thus the corresponding D2 over H has to be used when selecting the appropriate design chart. Okay, let's say we are using MZZ. Okay, moment dekat zigzag direction. So, corresponding H adalah dekat bahagian yang relate dengan MZZ. Okay, H. Okay, for in the other hand, kalau kita nak kira moment in YY axis, so kita punya corresponding H dah bertukar. Okay, so bila kita nak guna design chart, kita perlu tahu corresponding D2 over H. Depends on axis mana yang kita guna nanti. Okay, we will see more detail in the example later. Okay. Okay. Column, this moment is then increased by the nominal amount to allow for the possibility that the compressive load N is not at the center of the column. Okay, so the additional moment is calculated by multiplying the N by a nominal eccentricity E. Okay, so kita dah tahu nilai compressive load N. Okay, tapi kita tak boleh simply pakai ini sahaja. Okay, so kita kena multiply, kita kena ada additional moment which is multiply the N, the compressive load, by the nominal eccentricity. Okay, nilai E. So, nilai E ni kita boleh obtain melalui cara equation ini. H over 30, L naught divide by 400. Okay, H ni adalah dia punya height lah, size of the column. So, where L naught is the effective length ataupun height of the column. Okay. And lagi satu value E dia adalah 20 mm. Okay, so antara tiga ni yang mana yang paling besar itu kita ambil sebagai nilai eccentricity dia. Okay. Okay, use of column design chart. Okay, tadi kita ada sebut design chart kan. In a column carrying a bending moment and axial force, the calculation of the amount of the longitudinal reinforcement require an iterative solution involving a search for correct natural axis position. But by using this iterative solution is beyond the scope of this module. So maksudnya in our study we are not using this iterative solution. We are now focusing on how to use the design chart. Okay, so the design chart for rectangular column with symmetric reinforcement is shown at the end. I will show you later. Next, and this allow the reinforcement to be found without using this calculation. Okay, so the example, so this is the example of the design chart. Okay, this is the column design chart number 1. This is the D2 over H is 0.05. Okay, so we have a few design chart. Okay, depends on the value of the D2 over H. Okay, so this is 0.05. So this is 0.10, 0.10. Okay, so this is 0.15, 0.15, so 0.20, 0.25. So this design chart will be used depending on their D2 over H. Okay. Okay. All the longitudinal reinforcement will carry the vertical load. Okay. But the reinforcement near the center of the column will be less efficient at carrying the bending moment than daripada reinforcement near to the surface. Okay, maksud nak cakap kat sini adalah semua carry the vertical load, tapi yang mana yang paling yang berhampiran dengan center itu adalah less efficient at carrying the bending moment compared dengan yang kat tepi. Okay. Okay, for this reason, the different charts is available for different value of D2 over H. So, saya dah tunjuk. And ada value 0.10, 0.15, 0.20, 0.25. And it is always safe to use a chart for D2 over H value higher than the actual value required. Okay, so D2 ni apa? D2, what is D2? D2 is the cover plus size of the ties and half of the main bar diameter. Okay, so kalau let's say H yang ada dekat sini, so ini adalah corresponding D2 and H. Okay, kalau corresponding dia adalah H nya di sini, axis nya di sini, so D2 nya adalah di sini. So cover plus ties, size of ties, dan half of the main diameter. Okay, let's see the first example for this part. Example 9.4. A brace rectangular column 300 mm times 400 mm, concrete grade 30, carries an axial load of 1100 kN, and the maximum bending moment is 185 kN in the direction of 400 mm dimension. Determine the longitudinal reinforcement required. So dia nak suruh kita cari dia punya longitudinal reinforcement required. The column has an effective length, dia dah bagi dah siap, effective length of 2230 mm and not a slender column. Okay, sketch the reinforcement arrangement. Okay, so solution kita draw dulu lah dia punya benda ni. So this is B, this is H. So B is 300, H is 400 mm. Okay, so D over 2, D2 adalah cover. So this is the assumption. Normally we assume like this. Tie size is 8. Okay. And this is a half of the main diameter. So D2 is 50.5. Okay. So the axial load given is 1100 kN. So we need to check the nominal eccentricity E and which one is the greatest, and we will take it as a take the value. Okay. So this one is by using H over 30. So this one is the effective length or effective height divided by h. Okay, and divided by 400, not h. Okay, so this one is h over 30, this one is not divided by 400, and this one is the constant value, which is eccentricity is equal to 20. So by comparing these three values, so the greatest or the highest or the greatest value is 20 millimeter. So we adopt E, the eccentricity E is 0.02 meter. So the additional bending moment is the axial load times with the eccentricity. Okay, so this is the value of the additional bending moment. So the total bending moment is the given bending moment 185 plus with the additional bending moment. So moment now is 207 kilonewton meter. So D2 we already calculate 50.5. Okay, D2 over H. Not this one is not square. D2 over H. So 50.5 divided by H 400. So we get this value. So we need to use the chart for D2 over H is 0.15. Okay, for the use. So maksudnya tadi dia cakap ambil yang highest kan. So kita punya ada 0.13. Instead of using 0.10, so we use the chart for 0.15. Okay, so okay, untuk chart kita dah tahu dah. Okay, this is for 0.15 design chart. So kita dah tahu kat sini adalah M over BH square FCT. This one is N over BH FCT. Okay, so we need to calculate this value and this value first. So we got this value for moment, this value for axial load. So by using this value, we use the chart for 0.15. So we got this value. We got this value, which is 0.3. Okay. So by using this value, so we can calculate the value of AS. Okay, so we read by reading the curve. So kita dah baca dekat curve tu, kita dapat nilainya 0.3. Okay, so kita dah baca kat sini, dapat curve ni. So nilainya 0.3. Okay, so kita substitute di dalam equation itu untuk mencari nilai AS. So we can get the value of AS. Okay, so and also we need to check the minimum, which is the area of the longitudinal reinforcement should not less than this equation. Okay, so we calculate then, yeah, the value of area required is greater than the longitudinal reinforcement limitation. Okay, so then the cross section of the column is like this. We use 4 of H size H25 and 2 of H12. Okay, then provide is 2189, which is greater than the required. Okay, note that the additional H12 shown an open circle. This is not required for the strength. Okay, so maksudnya kat sini dia tak perlukan untuk strength, but dia provide untuk mengira untuk mengelakkan the maximum spacing. Okay, so the maximum spacing between longitudinal bar must not exceed the 150 mm. So maksudnya bila dia letak ini, so dia punya spacing is less than 150 mm. So that's all about the uniaxial bending moment. Okay, so kita kena tahu apa nilai D dengan ni. Okay, we continue in the next part for the next topic. Thank you. Assalamualaikum.